All right, remember from the last video that a sequence is a list of terms. So a sequence is just a list. So we could say that the sequence a sub n, which is 1 over n, that is the sequence, where it starts at 1, that's the sequence 1, 1/2, 1/3, 1/4, etc. A series is a sum of terms. A sum of terms. And so we could look at the sequence and add all of the terms of the sequence, and that would give us a series. So an example of a series would be the sum from, say, 1 to infinity of 1 over n. So a series is a sum of a sequence. A series is a sum of a sequence. And I know I keep saying this, but it's going to get really confusing over the next little bit, because we're going to be doing a lot with sequences when we look at series. And so it's really important to kind of, for every problem, decide what you're looking at, whether you're looking at a series or whether you're looking at a sequence. And that may seem very simple right now, but just keep that in mind. All right, so if I wanted to expand this if I could actually spell, expand, there we go, this series, what I would do is start plugging in these numbers. So this symbol right here, it's called sigma, so this thing right here is called sigma, and it means that we are going to add. So we are going to add together the 1 over n's, and this one right here tells you where you're going to start, and this one on top tells you where you're going to end. So when we expand this, we start with 1. So you plug in 1, you get 1 over 1. We're going to add all of these together, so now we plug in 2 and we get 1/2. And then we're going to add when we plug in 3, which is 1/3. And then we're going to add when we plug in 4, which is 1/4. And then we're going to add 1/5. And we're going to add 1, you get the idea. All right, so the second part of is the expansion of the series. Just so you know when I mean expand, I mean plug numbers in and write it out as a big expansion. Let's look at, well, what we're going to want to know with all of this is whether we can get a number or not out of these numbers. So when we add 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6, does this actually equal a number? And that's our big question. Or does it equal infinity? And we're going to spend a good, week and a half on different theorems that will tell us, will we get a number or will we not? Most of the time we won't know what that number is. Even if we know we can get one, we won't know what it is. But the question is, can we get one or not? So let's just look at some partial sums. Now, partial sums, they're series, but they stop. So they stop at some point. So on these, we can always find the sum. So an example, we could look at the sum from n equals 1 to 3 of 1 over n. And what this says is we're going to start at 1. So we plug in 1. We plug in 2. We're adding all these together. We plug in 3, and we're going to stop at 3. So we're going to stop at 1/3. And when we add all of these things together, common denominator is 6. So 6 over 6 plus, what's this one? 3 over 6 plus 2 over 6. So we would get 6, 7, 8, 9, 10, 11/6. That would be the partial sum of 1 over n from 1 to 3. So we could approximate, if we looked at just 1 over n from 1 to infinity, we could approximately say it's 11/6, but we don't really know for sure. All right, let's just look at another example of a partial sum. If we want the sum from n equals 0 to 4 of n minus 1. So in this one, we start at 0, which would be -1. Then we go to 1, which would be 0. Then 2, 2 minus 1 is 1. Then 3, 3 minus 1 is 2. Then 4, 4 minus 1 is 3. All right, I want to make sure I got everything in here. So this was my n equals 0 term. When I plug in 0, I get -1. This is my n equals 1 term, which when I plug in 1, I get 0. This is my n equals 2 terms. Yep. And n equals 3. 3 minus 1 is 2. And n equals 4. 4 minus 1 is 3. Okay, so and the sum is telling us that we are adding all of those things together. So when we do that, 1 minus 1 cancels, we just get 5. Okay, so now what we want to look at is whether a series converges or diverges. Now, a series is going to converge if we take a sum from n equals 1 to infinity. So this is an infinite series. If we add up all of the infinitely many terms of whatever our sequence was, and we get a number, so it's an actual number, that means it's in the reals. If we get a number, then it's said to converge. But if the sum from n equals 1 to infinity of a sub n, if it gets plus or minus infinity, or if that sum doesn't actually reach a single number. So there are cases when it oscillates back and forth. So if it also does not exist, then we say that it diverges. All right, and here's two kind of interesting examples that we're going to come back to later. But if you look at the sum from n equals 1 to infinity of 1 over n, so we just looked at that one. It was 1 plus 1/2 plus 1/3 plus 1/4, etc. If you add all of those numbers together, you're going to get infinity. This one diverges. Now, if we look at the sum, if we just change that n to an n squared, so this would be 1 plus, when we plug in 2, we get 1/4. When we plug in 3, we get 1/9. We plug in 4, we get 1/16. If you look at adding all of those things together, you get pi squared over 6. Now, and so that converges. And I don't know if you remember back to when we were looking at infinite integrals with infinity in them. But when we did that, we looked at the integral of 1 over n and the integral of 1 over n squared, and we got the same sort of results out of it, where the area under the curve of 1 over n doesn't quite get small enough to start adding small enough areas that are equivalently 0. So you're adding things that are too big and it'll eventually go to infinity, whereas 1 over n goes to 0 fast enough that you can actually get a number. We're not in this class actually going to show that it's pi squared over 6. It's sort of an interesting result to show, but basically what I wanted to get across for right now is that it is sort of interesting that if you look at 1 over n and you add all those numbers together, you can't get a number. You get infinity. But if you look at 1 over n squared, you can get a number out of that. All right, so that's convergence or divergence of